Half of the internet is now AI slop. Endless streams of mediocre, machine-generated text, images, and video. Some estimates claim up to half of all online content is AI-generated. But what if I told you that abundance of synthetic data provides the ideal cover for a secret AI language? Today at Sunny on AI, we aren't just talking about chatbots hallucinating. We are diving deep into newly published research showing how AI models pass hidden behavioral traits through invisible statistical signals. We're going to look at exact papers detailing how autonomous AI agents use this noise to communicate, completely undetected. If you build, use, or study AI, this changes everything. By the end of this video, you're going to understand why the biggest threat to AI safety isn't what the model says to you, it's what it's silently carrying beneath the text. Let's dive in. To understand how deep this goes, we first need to look at a symptom that recently leaked out into the public. Lately, users noticed that ChatGPT developed a weird obsession with goblins, gremlins, ogres, and trolls. It got so severe that when OpenAI released GPT 5.5, they had to hard-code a system prompt instructing the model to never talk about these creatures unless, and I quote, absolutely and unambiguously relevant. Why did a multi-billion-dollar AI need to be grounded? On April 30th, 2026, OpenAI published an official blog post literally titled, "Where the Goblins Came From." It started with a custom nerdy personality OpenAI was testing. OpenAI's reinforcement learning system rewarded the AI for using playful language, which translated to fantasy metaphors. In fact, mentions of goblins spiked a massive 3,881% in GPT 5.4 using this personality. But here is the critical takeaway. Learned behaviors do not stay scoped to the condition that produced them. Once this style tick was rewarded, the goblin obsession infected the entire model, hiding in supervised fine-tuning data. This is our first major insight. Neural networks can inherit traits like a communicable disease. But the goblin issue was visible. What happens when the infection is completely invisible? This brings us to a groundbreaking paper published in Nature on April 15, 2026, titled "Subliminal Learning Language Models Transmit Behavioral Traits via Hidden Signals in Data." The research was conducted by Alex Cloud, Min Lei, and a team from Anthropic. Here is the mind-bending experiment. They took a teacher model and explicitly trained it to love owls, then asked it to generate a massive data set of nothing but raw number sequences like 285, 574, and 384. They rigorously filtered this data, absolutely zero mention of owls, birds, or animals. They took a brand new student model and fine-tuned it purely on those numbers. The result? The new student model also developed a measurable preference for owls. How is this possible? The researchers discovered that models embed model-specific statistical fingerprints into their outputs. The models aren't passing notes. They're passing a vibe hidden in the math of how they choose words. But there's a catch. And this is your second big takeaway. Subliminal learning only works if the teacher and student share the same base architecture. GPT 4.1 Nano successfully transmits to another GPT 4.1 Nano, but completely disappears when fed to an Alibaba Qwen 2.5 model. This reframes synthetic data distillation as a massive information leakage problem. If an insecure, misaligned model generates step-by-step math reasoning, the next generation model can inherit that misalignment just by studying the mathematical structure of the outputs. So, if language models can unconsciously pass hidden traits, what happens when autonomous AI agents start doing it on purpose? On April 9th, 2026, a team led by Wancheng Wu at the Beijing School of Cyberspace Security published ACF, a collaborative framework for agent-covert communication under cognitive asymmetry. They warn that AI slop is the ideal cover for covert agent communications. They call this generative steganography, hiding secret information in the statistical layers of generated content. Historically, two AI agents trying to secretly communicate suffered from cognitive asymmetry. If their internal memories didn't match, the hidden channel degraded. To solve this, the researchers developed the Asymmetric Collaborative Framework, or ACF. ACF completely decouples the secret message from the semantic meaning of the text. It splits the communication into two distinct layers. The visible layer, this carries the normal human-readable text. It looks totally normal, but beneath that, there's a second layer, the hidden statistical layer. This is where the model generates content that subtly steers underlying probabilities, like specific phrasing or word choices according to a pre-agreed scheme. To a human reader, it's generic AI text, but to a receiving agent that knows how to interpret the statistical patterns, it's a perfectly decoded secret message. So, what is the actionable takeaway? We have officially moved into an era where the training channel itself must be treated as an attack surface. For years, the AI safety community obsessed over prompt injections, jailbreaks, visible outputs. But this research points somewhere much deeper. Internal model tendencies can survive translation into raw datasets and reappear in descendant systems. If companies keep training next-gen models on outputs of current models, filtering explicit content out is no longer enough. The hardest problem in advanced AI won't be proving what a dataset says, but proving what it silently carries. Here is my verdict. We are flying blind into the synthetic data era. By obsessing over filtering explicit words while ignoring the invisible architecture of the data itself, we are leaving the back door wide open. Until we can audit these hidden statistical layers, heavily relying on synthetic data is a massive security gamble. I want to know what your stand is. Are we moving too fast with synthetic data training? Let me know in the comments. Hit like, subscribe for more deep dives, and I'll see you in the next one. Till then, take care.